The two legs of a right-angled triangle measure 8 inches and 5 inches. How long is the hypotenuse? Here is a right-angled triangle. This angle measures 90 degrees. So the side opposite to this angle has to be the hypotenuse. The other two sides are the legs. Now, we're told that the two legs of a right-angled triangle measure 8 inches and 5 inches. So, this leg is 8 inches long and this leg is 5 inches long. What about the hypotenuse? Well, that is what we are asked to find. But how do we find it? Let's use the Pythagorean Theorem. This theorem says that the sum of the squares of the legs of a right-angled triangle is equal to the square of the hypotenuse of the right-angled triangle. Let's apply this to our question. We are told that the length of one leg of the right-angled triangle is 8 inches. So the square of this side will be 8 inches times 8 inches, which is 64 inches squared. Now, we are also told that the length of the other leg of the right-angled triangle is 5 inches. So the square of this side will have an area that will be 5 inches times 5 inches, which is 25 inches squared. Now, we can write this as 25 inches squared plus 64 inches squared, which is equal to the area of the square of the hypotenuse. Let's simplify this. 25 plus 64 is equal to 89 inches squared. So now we have 89 inches squared, which is equal to the square of the hypotenuse. We can simplify this in one of two ways. We can take the square root of both sides, or we can rewrite this as the hypotenuse times the hypotenuse, which is equal to 89. So what two numbers, when multiplied to each other, give us 89? Well, that number is 9.43. 9.43 times 9.43 equals around 89 inches squared. But if we do it the other way, the square root of 89 also gives us 9.43. So the length of the hypotenuse, 9.43 inches. Now, let's look at another example. Here's our right-angled triangle. One leg of the triangle is 14 meters. The other leg of the triangle is 5 meters. Find the length of the hypotenuse. Just like before, let's apply the Pythagorean Theorem. Remember that the Pythagorean Theorem says that the area of the square whose side is the hypotenuse is equal to the sum of the area of the other two squares. Here are our three squares. Let's find the area of them. starting with this one. We know that the side length of this square is 14 meters. So, the area is 14 times 14, which is equal to 196 meters squared. Now, we know the side length of this square, which is 5 meters. So the area is 5 times 5, or 25 meters squared. Now, to find the area of the square, whose side is the hypotenuse, we can add the area of these two squares. So let's add 196 plus 25, which gives us 221 meters squared. But we wanted to find the hypotenuse, and we found the area of the square whose side is the hypotenuse. So, to find the hypotenuse, we need to find what number, when multiplied into itself, gives us 221. That number is 14.866, since 14.866 times 14.866 gives us around 221 meters squared. So the hypotenuse of this triangle is 14.866 meters. Now, let's look at something a little different. This is Miss Green. She tells you that a right-angled triangle has a hypotenuse of 13 meters, and a leg of the triangle has a length of 5 meters. She asks you to find the length of the other leg of the triangle. What is your answer? Here's our right-angled triangle. We know that the hypotenuse is 13 meters and one leg, let's take this one, is 5 meters. So how can we find the other leg? Let's start by drawing our squares and finding their areas. This square has a side length of 13 meters. So the area of the square is 13 times 13, which is 169 meters squared. This square has a side length of 5 meters. So the area is 5 times 5, which is equal to 25 meters squared. Now, we know that if we add the areas of the squares that have a side as the leg of the triangle, we will get the area of the square whose side is the hypotenuse. But we only know the area of one square, which has the side as the leg of the triangle, and another square whose side is the hypotenuse. So to find the area of this last square, we can do the area of this square minus the area of this square. In other words, we can do 169 minus 25 to get 144 meters squared, which is the area of this last square. And to find the length of this leg, we can find what number times itself will equal 144, or just take the square root of 144 itself. Well, 12 times 12 is 144. So the length of the other leg of this right angle triangle is 12 meters. Let's look at a last example. The hypotenuse of a right angle triangle is 20 centimeters, and one leg of the triangle is 16 centimeters. Find the length of the other leg. Here's our right angle triangle. We know that the hypotenuse is 20 centimeters, and one leg is 16 centimeters. So how can we find the other leg? Let's start by drawing our squares and finding their areas. This square has a side length of 20 centimeters. So the area of the square is 20 times 20, which is 400 centimeters squared. This square has a side length of 16 centimeters. So the area is 16 times 16, which is equal to 256 centimeters squared. Now, if we add the areas of the squares that have a side as the leg of the triangle, we will get the area of the square whose side is the hypotenuse. But again, we only know the area of one square, which has the side as a leg of the triangle, and another square, whose side is the hypotenuse. So, to find the area of this last square, we can do the area of this square minus the area of this square. In other words, we can do 400 minus 256 to get 144 centimeters squared, which is the area of this square. To find the length of this leg, we need to find what number times itself will equal 144. Or we can just take the square root of 144. Well, 12 times 12 is 144. So the length of the other leg of this right angle triangle is again 12 centimeters.